Hey everyone, so I wanted to add a little video here in case you need some extra help with this activity. So for your 1.2 practice, which you can find in your modules, should be the next thing down. It'll have a date on it, February 12th. And then you click this and you'll go to a Desmos activity. It'll ask you for your name and then you can get started. Make sure to use your name so that I can come back and see how you did. Cool. So this first slide is just a welcome. We're going to go ahead and move to the next one. Alright, so we're given an equation, and we can see the graph of that equation right here, y equals 2x. So there's no number on the end, so we can think of it as a plus 0. But plus 0 doesn't really do anything, so we don't have to show it. So that's our y-intercept at 0. Then we have a slope of 2. So our slope describes our rate of change. In other words, our rise over run. So every time we go forward, or to the right, 1 unit, we go up 2 units. So you can see if we start at 0, 0, the next point would be at 1, 2. Go over another unit, go up another 2 units. So we want to adjust that slope so that we pass through this point right here at 4, 2. So you could take a minute to calculate what the slope would be, but I'm just going to kind of play around with it. So I'm going to take off the 2. Now we have y equals 1x. Again, 1 isn't something that's shown, because times 1 doesn't really do anything. So we're closer with that, but we need to slow it down a little bit. It looks like if I want to go over 4 units and up 2, that means I need to increase half a unit each time. So that's going to be my slope, 1/2. You could also write this as 0.5 if you prefer decimals. It's the same thing. Alright, so this looks pretty good. We're hitting both of these points at the same time with our slope of 1/2. 1 over 2. So we rise 1, run 2. Rise 1, run 2. 1 over 2. Alright, for the next part, you got to do a bunch of lines. So this will be some really good practice about how to move our line around. So notice that it says that each line should pass through the origin. So every line has to go through 0, 0. So none of these equations are going to have a number on the end. Because if we add a number on the end, then we'll slide our graph up or down if it's a negative number. So all we have to do here, all we're going to do here is manipulate our slope. Okay, so for this first point, I want to go through the point 3, 5. So from 0, 0, I need to rise 5 and run 3. So that's going to be my slope. My rise over run will be 5 over 3. Go ahead and check my work and see how I did. Nailed it. Cool. For the next one, I need to go up 1 unit for every 3 units I run. So again, going from the origin to this point, that's up 1 over 3. Your slope is your rise over run, so 1 over 3. So again, we start out with y equals x, and we're going to add our slope here, 1/3. So our y increases, or sorry, our x increases for every 1/3, our y increases. Again, we can check before we move on. That's looking pretty good. For these next ones, we've got to go down from 0. So again, as we move to the right, we need to go down. That means we need a negative slope. So again, I'll start with y equals x. But then if I look at my rise over run to get to this point, I need to go down 2 units and then forward 3 units. So my rise over run is going to be -2 over 3. And again, that's because I went down 2 units and forward 3. So let's see if we hit that one. It's looking good. So I'll let you figure out those last 2 on your own. But note again, if we need to go down and to the right, we'll need a negative slope. Alright, so there'll be a few more questions on this, which I'll let you kind of explore on your own. This one we have y equals 4 plus 6x. So this one looks a little bit different. Typically when we write a slope-intercept equation, we put the x part first. Usually it's mx plus b, but they've written it backwards here. So not usually how we see it, but you want to be careful. 4, the number by itself, still represents our y-intercept, like both of these people said. 6 represents our slope. Notice that our slope is positive 6, which means the line should be going up and to the right. Again, a positive slope will head up to the right, a negative slope will head down as we go to the right. So the blue looks more correct, which is, yeah. All right, and you want to explain your thinking. Don't just move on like I'm doing. I'm just giving you an overview here. All right, cool. If you have any other questions as you look through this, be sure to reach out to me. You can also come to Flex Time. I'll be available. Let's take a look at this last one. So I want to move my graph up to hit this point. So that's my y-intercept I want, not at 1, but at 4. I'm going to change this y-intercept, again, that's the number on the end, to a 4. Next, I need to increase my slope. It's not steep enough. I need to get up here. So to get from this point to that point, I rise 3, run 2. So that should be the slope I need to make that happen. Cool. Hope you guys get some good practice on this and reach out if you need some more help. Thank you.